Welcome to qnawire.
Okay, so this is the force diagram for the hoop. So let's take moments about point O. Consider counterclockwise moment is positive, clockwise moment is negative. And this will give us moment about point O is equal to FBR plus FAR minus PR is equal to 0. FB here is the friction at point B, and FA here is the friction at point A, and P here is the force P, okay? And this will give us FA plus FB times R is equal to PR. As you can tell, R here can be cancelled out, and this will give us force P is equal to FA plus FB. And we know FA plus FB can be expressed as mu S times NA plus NB. NA, NB here is the normal force at point A and point B. And mu S here is the coefficient of the static friction between the hoop and the surface of A and B. We are looking for to determine. Okay? And so now we know mu S times NA plus NB is equal to P. So now let's apply the force equilibrium to this case. So the net force along xy direction should be 0. So we have the net force along x direction is equal to Fa plus P minus NB is equal to 0. So we have force P is equal to NB minus Fa. And then the force along the y direction can be equal to NA plus FB minus W is equal to 0. Therefore, we have W is equal to NA plus FB. W here is the weight of the hoop. So we know Fa is equal to mu S NA, Fb is equal to mu S NB. So now we can set such two equations here, which is P equal to NB minus mu S NA, since mu S NA is equal to Fa. And let's say this equation here is equation 1. And then we have W is equal to NA minus mu S NB, since mu S NB is equal to Fb. And this equation here is equation 2. So now let's add these two equations together, and this will give us 1 plus 2 is equal to P plus W, and which is equal to NA plus NB minus mu S times NA plus NB. And remember, mu S NA plus NB is equal to P. So we have P plus W is equal to NA plus NB minus P. So now we have NA plus NB is actually equal to 2P plus W, since we can move the P to the left side. So now let's multiply by mu S on each side, and this will give us mu S times NA plus NB is equal to mu S times 2P plus W. And remember, mu S times NA plus NB also equal to P. So now we can set up such equation here, which is mu S times 2P plus W is equal to P. So now we can determine the coefficient of the static friction between the hoop and the surface of A and B if the hoop is on the verge of rotating, which is equal to P over 2P plus W. And this is the answer for this question.